Hey everybody, this is Larry, this is me going with Q3 of the Biweekly Contest 175, longest strictly increasing subsequence with non-zero Bitwise, and hit the like button and the subscribe button, join me in Discord, let me know what you think about this one. Honestly, I thought this was the most interesting problem of the set. I got a wrong answer because I didn't miss it, but I was kind of doing things a little bit suboptimally with respect to the strictly increasing part. The first thing I would say is understand the n squares. Oh, sorry. Well, I guess you should do that anyway. Understand the n square solution for longest increasing subsequence, and then after that, understand the n log n solution for the longest increasing subsequence. Right. I'm not going to go over it in the context of this problem. I wouldn't. Those things are honestly those problems are a little bit tricky for beginners even by themselves, so definitely go through it really quickly, or take your time. Really, don't do it quickly. I meant that way. Watch some videos, solve some problems on LIS, longest increasing subsequence, and then maybe come back afterwards, because for this video I'll consider it a prerequisite, and I'm not going to go over LIS too deeply. I am just going to go over the bitwise portion, and honestly once you understand LIS, then you know that's how you're able to solve a problem like this quickly, and I did it in 5 minutes, because then now you just have to focus on bitwise n, and the bitwise n is actually, once you understand the LIS portion, it's going to be just, if you're able to think about it the right way, well, it's going to be 90% of the problem is the bitwise n part, right? And what is a non-zero bitwise n? It just means that at the end of all the, if you select a subsequence, at the end there's one bit that is shared by all the numbers, at least one bit anyway. There could be multiple for sure, but at least one bit, right? And when you say it that way, does that make a little bit more sense? If it does, well, pause and see if you could, if you haven't solved it yet, then, pause and see if you can solve it that way. But that was my observation. Maybe it's not a tricky observation, but as a result, then now I go, well, now you're just trying to solve it for and actually I wrote this code not in this way, but I think now that I think about it more, this way is easier to explain and solve. Is that, okay, well, let's solve the longest strictly increasing subsequence for all the numbers that share a bit at, well, the first index, the second index, the second digit, the third digit, and then so forth. And then once you kind of loop it that way, and then you just obviously choose the best answer, and that's it. It is a plug and play after you realize that you only need the subsequence, because if you already filter out all of them by the bits that they would share at the end, then it just becomes much more straightforward. Of course, this is not cheap, right? As I said, the longest increasing strictly or otherwise is going to be n log n. Adding, it's a fast constant and stuff like that, but doing a bit at a time, basically solving the problem for each bit, it's going to just multiply by 32, right? Or in this case, technically 30, but but that's it. But that's the general idea. I wrote the code this way because I did it simultaneously. But now that I think about it, you really could have just done it the other way, and I think it's a little bit cleaner. I'll go over this way, and then we'll fix for the other thing. But because I think it's just a little bit more intuitive. But basically, yeah, for each number, I just go over bit by bit, and then for that, I take the best of that ongoing LIS, and then I do the LIS algorithm. This is the LIS code. This is the LIS algorithm. Not gonna go over it that much in this video. Like I said, this is the prerequisite. I have videos that go over it more detail, so search for that. But all I had to do was just do this. I mean, obviously, I'm gonna just run it real quick and make sure that it still works, so I'm not lying to you. So the loops doesn't matter, right? Hopefully, yeah, you saw, I don't know, it popped away quickly. But then as a result, then that means that now, instead of keeping all the things in memory at the same time, you can just do it this way. But even better than that, I mean, this is a nice way to kind of go from one way to the other, but even better than that is that now you could just write it this way, right? And now this is actually, strictly speaking, the LIS code for each bit at a time. And I you did the +1 because honestly, I'm a little bit rusty, and we watched the live portion. You'll see that I was a little bit rusty, but now I kind of remember why, because I should have like, because this is to represent 0 in the index. So if I had done that, I didn't need a +1, and this would have been fine, right? And again, this is n log n, right? And this is b, so this is going to be times n log n, where b is the range of numbers, and I always just add a couple for fun. But yeah, that's it. That's what I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve a live in contest next. Submit. Okay. No, so okay. Longest strictly increasing subsequence whose bitwise n is 0 is 10 to the 5th, and we have a big number, so it's not dp, at least not like the standard dp, right? Alright, and just define what subsequence is. So 5, 7. What would make it 0? Why? What does that mean? Bitwise n is non-zero. That means that they have to share a bit. What does that mean? Okay, so you have 7. What does the 7 mean? Well, the 7 means that you have bits, but I mean, the tricky thing is that you can't do it. Oh, I see. I guess you just do it at least one of the existing bits, right? And then you just kind of update 32 answers or whatever it is. Okay, I guess that's fine. Right. How does that work again? Yeah, you just update 32 answers. All right. How do I write it? Something like this. I think that might be actually more precise. Okay, and then now for x in nums, right? For b image of nope, not b, maybe small low b anyway. And now best of b dot binary search. Oh wait, you have to do an if statement. If x if this is the case, then we binary search strictly. So if it's the same, we want to go to the we'll go to the next number. Right. Okay, right. So then now, is this right? No. Well, I mean, man, it's been a while since I did LIS. So okay, so without the bit version, 1, 2, No, I mean that's fine, right? What am I thinking of? I'm thinking of the. Okay, yeah. Right, and then now that means that R is equal to max or index, right? But then now best of B. Okay, so then yeah, it's been a while. I'm a little bit rusty, honestly. We have pen x is the new thing, otherwise best of b of is equal to x, because now it is smaller by default, right? I think that's roughly right. 2, 3, 1. Int number has no. Did I set this wrong? Oh. Of index. Yep. Yeah, okay, that's off by 1. Oh yeah, because this is the index, So we actually, and we appended, so then there should be this +1. Hopefully that's right, and not just me fudging a number. I thought this was the case. Actually, I was thinking about. Maybe I should put it into the case, but that tie breaking was what I was thinking of. Why did I? So it was 1 because it was the same. I guess I was confused about this one because if it's the same, then we do it this way. Okay, maybe that's. Yeah, because then you insert it at the first instance. Okay, I guess that's fair. Messed up that one. Oh, this is crazy. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.